Assalamualaikum. My name is Hamza Ahmed, and the topic I will be explaining today is the slope of a normal line. Now, a normal line can be defined as a line that is perpendicular to the tangent line. Now, you might ask, what is the slope of a normal line? A slope of a normal line can be defined as the rate at which a normal line changes, or the rate of change of a normal line. Now, to explain this, I will be telling you about the slope of a normal function. As we know, function when projected on graphs have two types. One is a straight line and the other is a curve. Now, to find the slope of a straight line, we just need to take the derivative of that line and we can find the slope easily. But when it's a curve, we take a tangent line to it. Now, a tangent line is a line that touches the curve at a single point and only that point. And to find the slope of that curve, we find the derivative of the tangent line, and then we say that it is also the slope of the curve. Now, a normal line is a perpendicular to that tangent line that we drew on the curve. And the slope of a normal line is basically the rate of change of this normal line. Or in simple words, the rate at which y is changing, or like the value of y-axis is changing due to the x-axis. That is the rate of change of this line, is basically the slope of the normal line. Now, to explain this, I will be using an example. In this example, it's asked that we need to find the equation of a normal line to the curve of this function at the point 1, 0. Now, to do that, first we take that function and we take its derivative. After finding the derivative, we put the value of x in the equation and we find the derivative of f of x. Now, as you can see here, the value is 7. Now, to find the slope of a normal line, the formula used is m is equal to -1 by the derivative of function. Or basically, it is the negative reciprocal of a function. So now, if we put the value that we found, this is the value of the slope of a normal line. Now, you might ask that what is the purpose of finding the slope of a normal line? Basically, it is used in finding the equation of that normal line. So now that we know the slope, we can easily find the equation of that normal line by just putting these values, and we can form an equation that will be the equation of that normal line. And these things are basically used in engineering and architecture, and we can find the example of these curves and tangents. Normal line is always a line that is drawn by humans. It does not exist in real life. But the tangent line and the curves do exist in the real life examples, such as a tire and a road, or the basketball with the ground. When they touch, they form a tangent and a curve. Now, if we draw the perpendicular on that, then that will be the normal line. And if we need to find that equation of that line or the slope, we know what to do. So that was my topic. Thank you for listening. Assalamu alaikum.
Assalamualaikum. I am Mohammad Khobab, and as you know that you assigned me question number 6 of our quiz to make a video. So here I have question number 6. You asked me about that which rectangle has the smallest parameter with respect to x. So I want to state that square. State that square has the smallest parameter of all rectangles, and we can say that square is also a rectangle. Every square is a rectangle but not every rectangle is a square. There is a reason behind it, and that reason is that the sides of the squares, the four sides of the squares are equal, and the side of every rectangle is not equal. So I want to state that I also mentioned it in my quiz, that every square can be rectangle and every rectangle cannot be square, and the square is the one rectangle which has the smallest parameter of all rectangles. So here I want to state that sorry due to these noises, because I have the light issue. There is no light, and I can't make video inside my house. So here I have the mathematical form, as I mentioned also in the quiz, that the mathematical form, and I will explain the same. Let's be the xy, let xy be the length and breadth of rectangle whose area is A and parameter is B. So we are mentioning the length and breadth of the rectangle to prove that square has the smallest parameters. Let's say its parameter is B, and let's say its area is A. So as we know that parameter is equal to 2 into length plus breadth, or we can say it the width. Consider it the equation 1. Due to this camera, I can't show you. Here is the one. P is equal to 2 into x plus y, and I have area is equal to length into breadth, which is x into y, and from this equation I substituted the value of y, so we can say width, and that is area divided by length. Okay, so now putting the value of this width in equation 1, the parameter formula, so we will get P is equal to 2 into x plus A by x. Okay, so for maximum and minimum value of parameter P, we will take the derivative now. Okay, dp divided by dx, we will write it as dp divided by dx is equal to 2 into 1 minus a divided by x square is equal to 0. We have taken the derivative, and for minimum values we have changed the sign, that is we have applied the negative sign. Sorry for this noises, so I am really sorry. Okay, so we can write this equation as 1 minus a divided by x square is equal to 0. Then we will cross multiply it. It will be x square divided by a is equal to 0, and we can say that x square is equal to a, or x is equal to under root a. The dimensions of the rectangle are always positive. That's why we substituted the equation, and 2 is multiplied by the 0 on the other side, or we can say it's divided and it became also 0. Now taking the derivative again, we get d square b divided by dx square is equal to 2 into 0 minus a into minus 1 divided by x cube. This is by taking the derivative again. So we will get 2 into a divided by x cube, and it will become is equal to 2a divided by x cube. Now we have d square b divided by dx square, x is equal to under root a. The derivative of this is equal to, it will become like x is equal to, as we substituted in the minimum value of parameter in the first derivative, that a is equal to x is equal to under root a. So now putting the value of x, we will get 2a divided by a under root a whole cube is greater than 0. Okay, that is for x is equal to under root a. P, parameter of rectangle, is smallest. It became equal to the length and width of the parameter became equal to the length and width of a rectangle, that is square, and hence we can say that square is the smallest rectangle, square is the rectangle which have the smallest parameters. Thank you.
Assalamu alaikum, my name is Khalid and I'm from computer science department. I'm here to present the quiz in the form of the video that we were given by Dr. Nazir. So what I was given is Newton method. So let's talk about Newton method. Newton method is also known as Newton-Raphson method. So as the name suggests, it is named after Isaac Newton and Joseph Raphson. Now coming towards the main part, what is Newton method? Newton method is a root finding algorithm which produces successfully better approximations to the roots of a real valued function. In addition to that, Newton method is also used to solve algebraic or tangential equations. So let's move ahead. So is there any condition when the Newton method fails and we will not be able to use Newton method? It will no more be applicable. Yes, there is a condition. So Newton's method will fail in cases where the derivative is 0. When the derivative is close to 0, there will be a horizontal tangent line. So the point at which we get a tangent line, then this line will never hit the axis, as we all know, which will result in the derivative being 0. So this is the only condition where the Newton method fails. So here we have the formula of Newton method. So let's talk about the formula. Xn plus 1 is equal to xn minus function of xn divided by derivative of function of xn. So here we have an example of Newton method. So what is the question? Question is, using Newton-Raphson method, find the real root of the equation 3x is equal to cos x plus 1 to 4 decimal places. We have to find the answer up to 4 decimal places. So let's write the equation here. Fx is equal to 3x minus cos x minus 1. So we have to take the derivative of this function. As we all know, the derivative of 3x, we have studied 3 plus sin x, it will come up. The derivative of cos is minus sine. So as we have minus here, minus minus multiply, here we will get a positive sign. Then we will write the function again here. Now we have to get here two values, one is negative and one is positive. We will put some values here in the place of x. So in the first part we have put 0 and the answer has come up to be minus 2, negative. And in the second part we have put 1. Here the answer has come up to be positive 1.4596, as we talked about 4 decimal places. Now the intervals are 0 and 1. We have to let a number between these. We cannot let 0, neither we can let 1. We have to let any number between these. So here we have let x is equal to 0.6. So we have talked about the formula. Xn plus 1 is equal to xn minus f function of xn divided by derivative of function of xn. So here we will put the value xn minus function of x. As we have the value here, we will put the value here 3xn minus cos xn minus 1 over the derivative of function as we have calculated here. So we have put the value here, and after the simplification the answer is here. Xn plus 1 is equal to xn sin x, xn plus cos xn plus 1, 3 plus sin x. Now moving towards the remaining part of the question, and I want to tell you that here the answer is in radian. We have to convert it into degree. The one is in radian, we have to convert it into degree. So we will multiply 1 by 180 over pi to convert into radian. So that's why we have put it here 57.29, not 1, and the answer is 1.4596. Now we have to iterate it. We have to apply iterations. Now we will let n the value of n. We can let any number of values starting from 0. So x1, we will put the values x1 in this equation. Xn is equal to 1, then n will become 0, and we will get x1. N plus 1 will 0 plus 1 will get 1. So we will put all the value here and we will get the answer up to 4 decimal places. And similarly we have to again apply the iteration, and in this iteration we will put 1. So as we can see, 1 plus 1 will become 2. So here we have gained x2, and we will again put the value of n here. The x1 value here, it will become x1. X1 value was 0.6071. So we will put the value all over here wherever is needed. So we can apply it as long as we want. So hence the desired root is 0.6071, correct to 4 decimal places. Thank you.
Bismillah Rahman Rahim. The topic which is given to me is slope of normal line. So the definition of the normal line is that it is defined as a line that is perpendicular to the tangent line at the point of tangency, because the slopes of perpendicular lines, neither of which is vertical, are negative reciprocals of one another. So basically, the normal line is a line which is perpendicular to the tangent line. So for example, if we take a function f of x which is equal to x cubed minus 2x plus 4, and we are given with x-intercept that is equal to 1. So for y-intercept we'll put f of x is equals to 1. So the answer will be 3. Then we'll take the first derivative of the function, and the first derivative of the function is 3x squared minus 2. And now we'll put the x is equals to 1, the value x is equals to 1 in the first derivative, and the answer will be 1. So the slope of the tangent line is 1, and as I've said that the slope of normal line is perpendicular to the slope of tangent line, so the slope of a normal line will be the negative reciprocal of the slope of tangent line. So the slope of normal line will be minus 1. Thank you.
Assalamualaikum. My name is Hadabit, and the topic or the question which I have got for my explanation is question number 12, and the topic is slope of normal line. So what actually is a normal line? Normal line is the perpendicular line. As we have as we know that it's a perpendicular line. So first I will tell you that the normal line in a graphical method. So we can see that it's a y-axis, it's an x-axis, and on both of these axes there is a parabola, and in this parabola I have took this part. This is known as curve, and on this curve there is a point which cuts the curve at the one point. It's known the tangent line, and the point which cuts the curve is known as a point of intersection. At that point I have drawn a normal perpendicular line to the tangent line, which is known as normal line. So as the normal line is defined as the line that is perpendicular to the tangent line at the point of tangency. So for example, I have took the equation. This equation is the equation of that curve x cube minus 4x squared plus 5 at x is equal to 2. So I am going to find this. So first I have put the value of 2 in that equation, and I have got the answer y is equal to minus 3. So this means that this point has the coordinate 2 on the x-axis and minus 3 on the y-axis. So this is the point of we can say that points of intersections. So there are two methods to find the equation slope of normal line. So one method is that we can find through y is equal to mx plus b. But for both of the methods and the other method, let's I discussed with the passage of time. So other method is that for the slope of normal line, we have to find first the slope of tangent line, because we know that the slope of normal line is perpendicular to the slope of tangent line. So when so first of all I am going to solve for the tangent line. So for tangent line I have took the slope first derivative of the equation, and I have got the answer 3x squared minus 8x. So at the point, as I have discussed earlier, we have got the point 2 and minus 3. So when I put this point, I have got the value of minus 4. So this is the slope, like this is the slope of tangent line. So now let's come to method. One is that through this method, like I have written, we can substitute values, and I have got the answer minus 1 by 4. And the other method is that, which is more simpler, as normal line is perpendicular to tangent line, so we have to take like a reciprocal of the tangent line slope. So when I took the reciprocal, I have got the answer minus 1 by 4. So the slope of normal line is minus 1 by 4. So hence I have proved this thing through both of the way. Like when I put the value for first in this, I have solved for b, so when I got the answer -2, then I put and solve for m, so when I solve for m I have got -1/4. So thanks for watching this video.
My name is Mohammad Talal Ijaz and I'm from software engineering. So I have been assigned with the question 6, in which I have to tell the minimum parameter of a rectangle. So for this purpose, first of all, we draw a shape which would be like this, and we call this side as x and this one as y. So this side is let us suppose that we take it 100 centimeters square. So as we know that x is greater than 0 and y is greater than 0, so as we want to find parameters, so we write p, which is equal to x plus y plus y. P is equal to 2x plus 2y. So this is the basic equation that we have get. We can also write another equation as x dot y, which is equal to 100. So to simplify it, we just do y is equal to 100 divided by x. Now we're gonna put this value in here. So we get p is equal to 2x plus 2, 100 divided by x. So from this value we can find the minimum and the maximum value. For this purpose, we have to take it as a function, which we can do it p of x, 2x plus 2 dot 100 divided by x. Now if we take a derivative of this value, which becomes 2 plus 200 minus 1 and x minus 2. So because this is the derivative of this value, now to assume that we take this value, this value is equal to 0, which is equal to 2 plus 200 minus 1 x minus 2. So from here we can find the value of x. We're gonna solve this to get the value of x. 2x square minus 200. We're gonna there we have to just divide x square across all the values. We're gonna get 2, it's negative, it will come here to positive, and which x square, then 200 divided by 2 is equal to x square. This will become 100 is equal to x square. Then we can also write it like x square is equal to 100, and when we take under root both side, so there comes as plus minus 10. From this value we're gonna assign just only plus 100 plus 10, because we have mentioned here that x is greater than 0. So the minus 10 value will not be assigned. So this is also the critical point of this function, and this is also the value of x. Now if you want to confirm it, we're going to just take a double derivative of this, which will become double derivative of x. First of all, we're going to write the value which was previously written here, minus 1 x minus 2. Then we're going to take the double derivative, which will become 400 x minus cube. Then this will gonna become 400 divided by x cube. Now after that we put this was the double derivative. Now if we want to check, then we have to put some value, like if we put 10 in that value, which was 400 divided by x cube, 400 divided by x, which was 10.
Assalamualaikum sir, hope you are well. Today I am here to explain about the topic of ab initio method. So what is ab initio method? So ab initio method is the method of differentiation with respect to x. So let's say we say an example of something, some car. Okay, so it is gaining the speed and the slope is going upward. So we don't know that at the middle of this time, during the time, so we don't know that what was the speed of car at that instant. So here comes the ab initio method. So we will just apply the increment the, because the y delta y, let's say delta y is time and delta x is the speed, so both are changing with respect to each other. So we will increment both the delta x and delta y, and then we will apply the derivative. So when you apply the derivative, after that we will apply the limit, especially we will apply the limit of delta x approaches to 0, because we will have to find the rate of change at an instant. So now I'll explain you to an example. Let me come there. So let's say we have a function of y equals to fx. So where you know that when change occurs, so the change occurs both. Let's say we have y, let's say I have given the example before that y is time and x is speed, so both are changing. So we will say that y would become the y plus delta y and x will become x plus delta x. So then we will apply the first derivative, we will apply the derivative, and then we will apply the limit. So let me show you one example, a real example of me. So sir, we have a function y equal to x square. So we have to find the rate of change of instant using ab initio method. So first of all we will do increment the y and x. So we have increment the y to y plus delta y and x to x plus delta x. So after applying the derivative, first derivative, we came to know that the rate of change is equals to this, but this is not exactly at an instant. So just we will apply the limit, and we will apply the limit delta x equals to 0. So it will give us the answer at 2x, which is 2x. So it is at a rate of change at an instant when the x approaches to 0. So you know that the x approaches to let's say we have a point A and point B. So we have the rate of change of x in between both these points. So if we want to find the rate of change of x, rate of change at point A, so we will we have to apply the condition that the rate of change would approach it to 0. Then we can find the exactly at an instant the rate of change of point A, here at point A. So this is the concept of ab initio method, sir. So I have thoroughly explained about the ab initio method. Hope you liked the video, and take care, sir. Allah Hafiz. Thank you, sir.